I'm Anil Kumar sharing with you some questions from previous test paper. Here is question number 3. We'll discuss how to find limits of functions. So we have 6 parts in this particular question. You can always pause the video, answer the question, and then look into my suggestions. We need to evaluate the following limits. Limit when x approaches pi for 3x. Limit when x approaches square root of 2 for 5. Limit when x approaches 2 for 2x square minus 7x plus 6 over 4x minus x cube. Limit when x approaches 4 for 3x cube minus 12x square plus 5x minus 20 divided by x cube minus 64. Limit when x approaches 4 for 4 minus square root 12 plus x divided by 4 minus x. And limit when x approaches 27 for x minus 27 over cube root of x minus 3. So we're going to use different concepts learned as we go through these 6 questions based on limits, right? So here we'll use substitution, in this case rationalization. In these 2 cases we'll factor and simplify, and first 2 are straightforward, correct? So here we have 3x and x equals to pi. So how do you find this limit? Just substitute pi there, so we get 3 pi as our answer. Now in this particular case, we have limit. The function is a constant function, right? Remember, this is a constant function, correct? So it is always going to be 5, whether you check it at square root 2 or any other number, correct? So that is how we do them. Now others will do it on separate sheet of paper. Meanwhile, you can always pause and answer these questions. So now let's take up part C, which is limit when x approaches 2 of this particular function. Now if I write 2 in the denominator, I get 8 minus 2 cube is also 8, right? So it is denominator 0. If I write 2 in the numerator, you will find that that is also 0. So this is 0 over 0 form. It is indeterminate. So we will actually factor and then solve. These zeros are because of a factor. So when we factor, we'll get a common factor in numerator and denominator, cancelling that and then substituting 2, we should get our solution, right? So the question here is to find limit as x approaches 2 for 2x square minus 7x plus 6 divided by 4x minus x cube. We could write this x approaching 2, right? So it is limit when x approaches 2. So it's a question of factoring, right? 6 times 2 is 12. So we need to get product of minus 7. So what could the 2 numbers be? 4 and 3, right? Both negative. So we can write the numerator as 2x square minus 4x minus 3x plus 6. Now some of you can actually do the factoring separately and then do the needful, right? So that is also possible. Let's take x common here. So let me take minus x common. So if I take minus x common, I could write this as x squared minus 4. Perfect. Okay. So we could rewrite this as limit x approaches 2. The numerator, taking 2x common, we have x minus 2. And here taking minus 3 common, we get x minus 2. So that is what we were expecting, right? A factor of x minus 2. And this could be written as x plus 2 times x minus 2, correct? We have nearly factored it. Let's finish it off. So now we have 2x, 2x minus 3 times x minus 2. X minus 2 is a common factor, correct? Over minus x times x plus 2 times x minus 2. So we can now cancel these 2 common factors. That really means we have a whole, right? So that means just a note that gives you whole at x equals to 2, right? So whenever you cancel, you have to write x is not equal to 2. Is it okay? So we have an equivalent expression here. So finding limit with an equivalent expression is the whole idea. So now we have an expression which does not have this factor, which was making it 0. So let's rewrite this. We have 2x minus 3 over minus x times x plus 2. Substituting 2 here, we get 2 times 2 minus 3 over minus 2 times 2 plus 2, right? So that is 4 minus 3 over minus 2 times 4. That is 1, this negative, let me write here, over 8. So we have the limit as negative 1 over 8. So the limit of the function is minus 1 over 8. So that is how we can actually solve such a question. So I hope that makes sense. Now let's take the next part, which is question 3D. We need to find limit of the given function as x approaches 4. Again, if you substitute 4 here, we get 0 over 0. So this is also 0 over 0. So what we are going to do? We are going to factor. So let's do it. So we get limit x approaches 4. The numerator, you can see that these two terms have 3x square common, and this has 5 common. So let's do that. So we could write this as 3x square, and in the bracket we get x minus 4. Here if I take 5 common, we get x minus 4. Denominator, we have cube, right? 64 cube is basically cube of 4, right? So a cube minus b cube formula will be applied. Let me write down here formula for a cube minus b cube, which is a minus b times a square plus ab plus b square, correct? So that is the formula which we are going to use to factor it further. Now, so b, which is 4 cube, so we get x minus 4 times x square plus their product, which is 4x, plus square of 4, which is 16. So that is your denominator, correct? Now, in the numerator, we have x minus 4 as a common factor. So I'll take x minus 4 common. We are left with 3x square plus 5. Denominator has x minus 4 as a factor. We have x square plus 4x plus 16 as the other factor. Now, you can cancel the common factor. So again, there's a whole at x equals to 4, right? So we get limit x approaches 4 for 3x square plus 5 over x square plus 4x plus 16. So when you substitute 4 here, what do you get? 3 times 4 square plus 5 over 4 square plus 4 times 4 plus 16, right? So this is 16, 3 times 16 plus 5. You can do this math. And we get 3 of these 16s, right? So 3 times 16. This is also 16, 16 and 16, correct? So that's what you get. And our answer now is 6, 8, 18 and 148, right? Plus 5 over, we have 3, 6, 18, so we have 48 here. So the answer here is 53 over 48, correct? So that becomes the limit of this particular function as x approaches 4. Part E. Evaluate limit as x approaches 4 for 4 minus square root of 12 plus x over 4 minus x. So we need to find limit as x approaches 4 for 4 minus square root of 12 plus x over 4 minus x. So again, if I substitute 4 here, this is 16, the square root is 4, we get 0 over 0. So in this particular case, we'll do rationalization. So wherever you have square root, we should do rationalization. Now since the square root is in the numerator, we'll rationalization of numerator. What does that mean? It really means that we have to multiply and divide by the conjugate, right? So let me show you what it means. So we have this function 4 minus square root of 12 plus x divided by 4 minus x. We'll multiply and divide by its conjugate, which is 4 plus square root of 12 plus x over 4 plus square root of 12 plus x. Is that clear? So when you do so, we get difference of squares, right? So since you know that a squared minus b squared is actually a plus b times a minus b. So we have situation a minus b times this. So what we get is difference of squares. So the numerator now becomes 4 square, which is 16, minus square of this, which is 12 plus x, correct? Denominator, we'll write both the factors. 4 minus x times 4 plus square root of 12 plus x. Now, let's simplify the numerator. We get limit. As x approaches 4, we have 16 minus 12 as 4, so we get 4 minus x. Right? 16 minus, we get 4 minus x in the numerator, divided by 4 minus x is a factor which can now be cancelled. That was the idea. Since it was 0 over 0, we knew there is a common factor, which is 4 minus x or x minus 4. So it could be cancelled. So rationalization helped us to do it. So we have limit x approaches 4. And now what we get here is 1 over 4 plus square root of 12 plus x. Correct? Now we can substitute 4 here. So we get 1 over 4 plus square root of 12 plus 4, which is 16. So we get 1 over 4 plus 4, right? Or we get 1 over 8 as our answer. So the solution for this is 1 over 8 is the limit for the given function as x approaches 4. Now let's take the last question of this series. We need to evaluate the limit x approaches 27, x minus 27 over cube root of x minus 3. So if I substitute 27 here, we get 3. 3 minus 3 is 0. 27 minus 27 is also 0, right? So it is again 0 over 0 form. In this case, we'll use substitution method to find the limit, correct? So let us say that let u be equal to cube root of x. In that case, u cube will be equal to x. This is first thing, correct? Second is the limit. So when x approaches 27, right? So u approaches what? U approaches cube root of 27, correct? So u approaches 3. Do you see that? So these things are important. So whenever you do substitution, you have to also see how does the limit approach, right? So let's rewrite the equation with this substitution. So we could write this as limit u approaches 3 and x is equal to we wrote u cube is this x, right? So instead of x, I'm going to write u cube. So I'm going to make this substitution for x. So we get u cube minus 27 over, we have written u as cube root of x, u minus 3. Do you see that? So again, we'll use the factoring formula of a cube minus b cube to solve this question. So we could now write this as limit u approaches 3, and the numerator could be written as u minus 3 times u square plus product of these two, which is 3u, plus square of 3, which is 9, over u minus 3, correct? So u minus 3 cancels, so we get limit u approaches 3 of u square plus 3u plus 9 over 1. Let me write like this. So as we can see, this cancels. Second, about the factoring part, so if it is a cube minus b cube, as I said earlier, could be written as a minus b times a square plus ab plus b square. So we use this formula to factor. Perfect. Now we can substitute u to find the limit. So we get 3 square plus 3 times 3 plus 9, which is, so these 3 9s, right, which is equals to 9 times 3, 27. So the answer is 27. So that becomes the solution for the given question. Perfect. So this limit is 27. So I hope you understand now how to find the limit of functions and how to use these different techniques. So we've effectively utilized three techniques here: factoring, rationalization, and substitution. In all these three cases where we used these techniques, the functions were indeterminate, since substituting the value gave us a form 0 over 0. 0 over 0 also indicates that there is a common factor in numerator and denominator. These techniques helped us to identify those factors and simplify the expression. So that is the whole strategy behind it. So I hope the concept is absolutely clear. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.